The homework? I'll explain it.
I know.
All right, everybody ready?
Yes, sir.
All right, let's get rock and rolling. I need to take attendance in just a minute. Optimization. Optimization is the topic that we are going to continue on for the next 2 days. Optimization problems are always application questions that you are trying to find the best solution. And by best, I'm talking about like words like most, least, greatest, smallest, extremes. And I want to use that word extremes so that you start thinking about absolute max and absolute min. Are we okay?
Yes, sir.
We are looking for highest points. We are looking for lowest points. And we have an extreme value theorem that says there always is a highest point and there always is a lowest point as long as two conditions are met. A continuous function
On a closed interval.
on a closed interval. So whenever we're looking at a continuous function on a closed interval, you will have an absolute max, you will have an absolute min, and everybody's okay? All right, I'm going to take attendance. I need you guys to give a read through this model problem number 1. Come up with your strategy. What would you do if you were faced with this on Wednesday's quiz? We'll talk in just a bit. Take out, let's forget crying.
Mr. DeRozier.
We have a total of 32 yards of fencing in order to place the garden side to place the garden right next to a building in such a way that the building forms one side of the garden and the fencing they use all of the fencing available. What are the dimensions of the garden?
Largest second period. Fourth period is a little second. About 2/3 right.
Oh wait.
All right, let's get into this. Ms. Pandy and the Gardening Club are planning a new garden for the Southwest campus. They have a total of 32 yards of fencing available to place around the garden. They've decided to place the garden right next to a building in such a way that the building forms one side of the garden and no fencing is needed. Assuming they use all the fencing available, what are the dimensions of the garden which generate the garden with the largest area? Show the work which supports your answer. This is an optimization question. When you read this, Adrian, I want it to scream at you, optimization. Why? What did you read that says, oh my God, it's an optimization question? Jeanette? I want the largest area. So I'm going to look at the area, and I want to make this as big as I possibly can, for whatever reasons. Now, some strategies that I heard, some people were like, hey, I'm going to start making some guesses. I'm going to say that this side over here is 12, and that's 10, and that's 10.
No.
Does that meet the constraints of the question?
No.
Yeah.
What about the other?
What was that, Diego?
It uses all of the fence.
It does use all the fencing, right? I've got 32 yards of fencing available. And if I want to make the area as big as possible, I want to use all the fencing. I don't want fencing left over. I want to use as much as I can. Henry?
But you can still make it different dimensions.
Okay, so maybe you want to go with 12, 10, and 10. Maybe you want to go with different dimensions. Like maybe you're like, oh, how about 16, 8, and 8? Right? And you could go like process of elimination through this and maybe come up with the best answer. Is everybody okay?
Yeah.
I want to attack this like a calculus student. And so rather than guessing, let's use some variables. Well, what do we know?
You have 32 yards of fencing.
32 yards of fencing. I'm going to say that F is 32 yards. And that fencing goes here, it goes here, and it goes here. We're going to do some calculus. We're going to take some derivatives. We're going to do all the fun stuff. So I need to come up with some variables that are going to represent this side, and this side. So maybe you want to call this guy L. Does this have to be L?
No.
No. Let's call it like something else, right? W. What about this side? Does this have to be L?
No.
The W, right? Because it's a rectangle, this has to be the width.
Yeah.
So there's a constraint, and that's just a fancy word for what's going on here. The constraint is I need to use all 32 yards of fencing for all three sides. So the constraint equation is going to look like this. If I take the length plus 2 times the width, we're going to have to be equal to 32. Everybody okay with the geometry there?
Yeah.
Okay. And then there's also an optimization equation. What is it that we're trying to make big?
The area.
The area. What's the equation for the area?
Length times width.
Length times width. Now, usually, when we've been doing these problems before for homework, I've given you the optimization equation and I said, go find the absolute max. Go find the absolute min. Right? What's the first thing you do?
Find the derivative.
You want to find the derivative. Why?
So you take the number that could be, I forgot what it's called.
The candidates.
Candidate.
Okay, so what I heard Andy say is we're going to take the derivative, we're going to set this equal to 0 to find what we call the candidates. Anybody have a problem with finding the derivative here?
There's 2 variables.
You've got 2 variables here. We have not yet, but we will. Wow, I can't wait. It's after Thanksgiving break. Area equals length times width. We have not come up with a way for finding the derivative when there's multiple variables in here. Good news, you don't actually have to use both variables. You can get clever and use the constraint equation. Because what we know from the constraint is that length plus 2 times the width is equal to 32.
Yes.
So what?
Solve for one.
Isolate.
Right? You can isolate, you could solve, but trust the instincts. This is what I want to take a derivative of, but I can't because there's 2 variables. I've got this other equation, let's use this. If L plus 2W is equal to 32, that's the same as L equals 32 minus 2W. And if I plug it in, now I'm going to get area is 32 minus 2W times W. And I hope everybody's okay with this. This is your optimization equation. What Andy told us to do is what we're going to do next. We're going to find a derivative. We're going to
Equal to 0.
set it equal to 0 to find those candidates. Okay, options for finding a derivative here. Product rule, that's one option. Other thing, you could distribute, you could do the algebra first. Given a choice, I might distribute first. So area is 32W minus 2W squared. Okay, Adrian, what's that derivative going to be?
32 minus 4W.
32 minus 4W is the derivative. We're going to set that equal to 0. You're going to find your candidate. I bet most of you guys can just look at this and you know what the candidate is.
8, positive 8 or negative
Careful. 32 equals 4W, so W equals 8. W equals 8 is your candidate. This is the place where you might have a max. You could also maybe have a minimum and you don't really know yet. Is everybody okay with coming up with 8?
Yes.
Okay, so now I want to back up on this thought. The extreme value theorem says what again? The extreme value theorem, what does it say? You have a continuous function on a closed interval. What happens?
You have
You have a
Must have a max, must have a min. Let's come back to this problem. Do we have a continuous function?
yes.
32W minus 2W squared, that's a parabola. That's continuous. Do we have a closed interval?
Yes.
Well, yeah.
It's a 32.
Maybe. We're not really sure. If there is a closed interval, you have to identify what that interval is. What's the smallest width? What's the largest width? Okay, this is the part where I know on Friday I lost you guys for a bit. Have a quick conversation with somebody near you. What's the smallest the width could be? What's the largest the width could be? What's that smallest and what's that biggest?
I'll see you on the back.
I disagree with both. Looking for that smallest width.
Smallest is zero.
Say one.
Smallest width.
Oh, no.
Okay. Smallest width you could possibly have.
Zero.
Somebody told me 0. Somebody told me 1. What's the smallest the width could ever possibly be?
0.
Paul?
Point zero, like
Okay, originally Paul said 1. Meaning the width, that's what you said originally. And your thinking is sound, like, well, the width couldn't ever be less than 1 foot. Or could it be less than 1 foot? Could I make the width less than 1 foot?
Yeah.
Like half a foot?
Yeah.
Like a tenth of a foot?
Yeah.
Like 100th of a foot?
Yes.
Yes! What's the smallest we would ever consider the width to be?
0.
Okay, I'm gonna say 0. And I know a lot of you guys are gonna argue like, that's stupid. You have 32 feet of fencing, and what did you do? Nothing over here, nothing over here. You ran the fencing along the building. But that's the smallest it possibly could be.
Can't you just take off the equal to sign?
Oh, thank you for being there for me.
You're welcome.
Thank you for being there for me. You just made our world fall apart. Okay, let's look at the largest value for the width. What's the largest the width could be?
32.
2 popular answers are 32 and 16. Width. I have 32 feet total to play with here. These have to be equal to each other. The biggest the width could be, Andy, is I use all the fencing for the width, which is going to be 16. Okay, Sylvia, I'm going to explain why the world falls apart here. Is everybody okay with the inclusion of 0 and 16 as smallest and biggest? Okay, let's go over the criteria again. What are the 2 things that we need? Continuous. Got it. What's the other one? Closed interval. Closed interval. Closed interval means you include the endpoints.
Oh,
Sylvia, why does the world fall apart now?
because that if you would take that off, it wouldn't be a closed interval.
It's no longer a closed interval. If you can't get all the way to 0 and 16, you can't use the extreme value theorem anymore. There will, Paul, I see you. There will be problems where this is going to be real. Not today, though. Paul.
The thing I don't get about including 0 is like, you want to optimize it, but if the width is 0, then the area is 0.
I agree. But if you have a closed interval and you have a continuous function, then we are guaranteed by the extreme value theorem that there will be a max and there will be a min. And we know how to find it. Oh my God, we know how to find it.
Oh yeah, I agree.
We got the candidate. We've got the endpoints. What do?
Plug it in.
Evaluate, right? Evaluate what you're trying to maximize. Evaluate the area. So the places I'm going to evaluate are 0, 16, and 8. Find the area in all 3 cases. Area is 32 minus 2 times 0 times 0. 0, not a surprise. Area is 32 minus 2 times 16 times 16. 0, not a surprise. Last one. Area is 32 minus 2 times 8 times 8. Okay, some math required here. 2 times 8 is 16. 32 minus 16 is a 16 times 8. 128. Because you have a continuous function on a closed interval, I know and you know the only place I could have a max would be at the endpoints or the internal candidate. If I don't have endpoints, I can't make this argument anymore. Yeah.
How did you get 0 for where W equals 16?
If W is equal to 16, 32 minus 2 times 16. 2 times 16 is 32, 32 minus 32 is 0. Everybody okay?
Yeah.
Go back and answer the question now. Assuming they use all the fencing available, what are the dimensions of the garden which generate the largest area?
And the width is 8.
Okay, area is largest when width is, what did we say? 8, I need units.
Yards.
Whoa,
Yards.
yards. Okay, and what's the length?
4.
Yeah.
What's the length gonna be?
4.
So not 4?
2.
Not, oh my god.
4 yards.
I thought the worst thing that was going to happen to me today was falling in the hole and having recycling all over me. This might be worse.
16.
Thank you, Julissa. How did you get 16?
Oh.
We said that the constraint was that it's length plus 2 times the width. And since we
Length
have
plus 2 widths is 32, which is the same as saying L equals 32 minus 2W. We know what the width is, we can go find the length. So the length is going to be 16 yards. Okay, here's what you guys are going to do. I want to give you guys the next 10 minutes to work on case 1 and case 2. There's 2 more application questions. It looks a lot like this, but I've changed some things on you to see what you can do. 2 nights homework that you are turning in tomorrow for a grade is to finish up case 1 and case 2. You've only got 10 minutes. Do the best that you can with the time that you got. Get a good start. I'm going to hobble around, see how you're doing. It's the very next page. Okay, Jeanette. Jeanette, do you have the test corrections in the reflection document for me? You will have them for me tomorrow. Diego.
No? So what is it?
Oh, so we are rolling this into the amnesty place that's going to happen.
So much fun, man. We can see the excitement give it. Let's solve this problem again. The gardening club.
That'd be even better. Jackie. Oh, we already talked about that.
Break it down. Area is going to equal
Yeah. What does that say? Free response corrections? Question mark. Like, I found your multiple choice corrections, but I didn't see any response corrections.
well, there's no
Okay, Chris, this is not the mean value assignment.
I think 0 is my favorite number. Whenever I see a 0, I get so happy.
Okay, it's definitely assignment 54. That's the thing I wanted you guys to do this weekend. The mean value theorem assignment is assignment number 52. You got me? Assignment 52 is the mean value theorem.
You don't need this?
Well, if it's
Can't wait to get past these easy ones.
These are easy?
Of course.
Oh, yeah.
Yeah, of course, Henry. But you're a DeRozier. I think you were the first to become a DeRozier.
Is there?
You were sucking up from day one, weren't you? No, Paul and Adrian beat you to it. They started on the spring trip last year.
oh yeah.
Uncle D. Right, so that's what becomes the hard part with the observation. It's the start, you need to read the studies really carefully. Label everything in a way that's going to make sense. So let's help pop again. This time the cardinal class is going to two buildings to form a side of the garden.
Oh, yes, Daddy.
But it's still 32 yards.
Because of the building had a area of so there's like
Are they like, no, they're Love it. Love it. Oh my God. Love, 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 love. Love.
Big 120 on 40.
Don't look up there.
Like 60 or something. Like I was just like very normal. I know it's
So let's start with labeling this guy.
oh yeah, but like no, I was very like backwards. The kid can walk. Yeah, for now.
When
Catch me back.
Move it over. Good. So you're to figure out what's the biggest and the smallest. There's not a like thing that you do. You need to like think through this. So in this situation, I see you, Jackie. If my area is a function of the width, what's the smallest that the width could be? The smallest.
Oh, 0.
0. What's the biggest the width could be?
I'm always banging. My nose reaching right past me.
He's saying 16 because he's stuck on the last question. Look at the geometry of this problem. What's the biggest the width could be if I have... Why 32 this time? I'm only worried about the width over here. I don't have a matching width where I'm using the fencing. So your interval this time is going to be 0 less than or equal to W less than or equal to 32. It's the geometry of the problem that's going to dictate smallest and biggest. Okay? Friends over here, how are we doing? Okay. Are we getting 16 as the candidate?
Oh, wait. I thought the whole lot was case.
we would evaluate the area with like the smallest and largest. I mean, the areas here are the same, but you need to find the biggest. I need if I don't see steps whenever I go back to my notes, I'm like,
Now here's the thing.
oh.
Okay, I see what you're telling me over here. I don't like what you're telling me over here. W equals 0 equals 0. W equals 16 is 257. W equals 32 is 0. I'm going to read this thing. Oh my God. All what's that? 32 is W equals 32 is what?
At first, I multiplying, I would draw the line and then go there.
The area is equal to 0. So W equals 32, area equals 0. Show it in here. All right. Okay, so she was well on the first one. The width being equal to 16 yards is what's optimized.
What does that mean? I know, like, I know that 16 is the minimum.
Yeah.
The large is width being 16 and like 16.
Yeah. That would be the guess area.
So how come on this one it was the smallest was 0 and the biggest 30?
The geometry is
Oh,
because you have that second building, you're not putting fencing over here, you're only putting fencing here and here. So you could have a width of 32.
oh, and then I have like 0.9%, like 0.9.
Alrighty, friends, here it comes. All the good stuff's coming, Mr. Harper. All right. Just to make sure we're all on the same page, tonight's homework on optimization is just to finish off case 1 and case 2. I am being kind in the world of optimization because I want you to feel good about yourselves. I never came to you? Too bad. Okay. Sorry. The homework that was due today that you all came in expecting to turn into me today is going to be turned into me tomorrow. And all of you that have dug a hole over like last week, we are digging out of this hole by Thursday. Everybody on the same page? Yes, sir. We have a quiz on Wednesday. So my grade book is going to have a lot of changed grades between now and when we leave for Thanksgiving. All right. Das ist good. I want to take you to a scarier problem. I maybe left enough room for you to do this. Maybe. Garrison, can you read the introduction to this problem?
A rectangle is bounded by the x-axis and the semicircle y equals square root of 15 minus x squared. What length and width should the rectangle have so that its area is a maximum?
Okay. Does this count as an optimization question?
Yes.
Jeanette, why? What is it that you see that right away you're like, oh my god, it's optimization?
Maximum?
I'm asking for a maximum, okay? I want a maximum. This is a calculus question. We're going to do all of the things. Before we get into this, can somebody turn the lights off? Val, can you turn the lights off in the back? I want to show you. Okay, how about just one? Because that got really scary. And somebody was just talking to me about Pennywise the Clown, and the lights went off, and inside I was like, ah! All right. So check out what's up here. Thank you to Audrey Weeks of, oh my gosh, Calculus in Motion. We've got the semicircle. We've got the rectangle. Everybody agree?
Yeah.
Rectangle is inscribed in the circle, just means rectangle is inside the circle. And what I want to do is I just want to animate this.
Ooh.
Okay? You can ooh and ah all that you want. Okay? The question is, what is the x value? How do we build this rectangle so that its area is a maximum? Okay, so we've got the rectangle. I'm changing the width of the rectangle. As I change the width of the rectangle, the height has to decrease to stay on the circle. Is there a rectangle that has the greatest area?
Yeah.
Check out what's on the screen.
No.
No.
There, okay, so we're getting some no's that there's not going to be an area, rectangle with the greatest area.
Oh yeah.
If you pay attention to the data on the screen, you might start to think, oh yes, there is a greatest area.
15.9.
And that greatest area, depending on how close you are to the front, you might see it if you watch the values 2, 9, 10, 11, 12, 13, 14, 15, 16, and then it starts to decrease.
15.92.
15.92. Let me see if I can like really get going here.
Let's go with Shadid.
All right, here we go. Here we go. I'm going to stop the animator. Oh my! My day's getting better all the time.
Let's go.
All right.
That's the answer.
Okay. As I change the x value, as the x value becomes smaller, the rectangle becomes taller, and the area gets less.
Yeah.
Okay. What do you guys want me to do with the x value here?
Make it greater. Yes.
More.
More?
Yeah. More.
A little more?
Not enough. Over 9,000. What do you want?
Ah.
A
A little bit more, mister.
Write that down. That is the largest area. Okay? Right now we're just going to make a note that the largest area is going to be 16. What's the value of x that makes that happen? 2.821. Now, we have done absolutely no calculus whatsoever. We cheated. We went to a computer program and we found the answer. And some of you might be like, that's good for me. Michelle's like, I'm going to keep my 100 if I do that. Yes, Ebel, let's turn the lights on. And now it's time to do the calculus.
Yeah.
Yeah, because that's why we're here. Okay. In order for us to work this out using the calculus skills, I need to come up with the equation I'm trying to optimize. What is it that I'm trying to optimize? What are you trying to make as big as possible?
It's a rectangle. The area.
Not the rectangle, not the x-axis. What are we trying to make really big? Go back and read the question. Area.
Area.
I need an equation for the area. Well, it's the area of a rectangle. Length and width.
Oh yeah.
Now, the x that I'm using represents the distance from the origin.
Oh.
Okay? So how long is the rectangle? 2x. How tall is the rectangle?
X.
It's not necessarily x. What it is, it's the y value on the circle. However far to the right I'm going, I go up until I hit the circle. I hit the point on the circle. And oddly enough, BC friends, this is exactly what you guys are doing with your area computation. We're saying at this x value, what's the height? You look at the y value. The y value, you might say at first, well, the area is a equals 2x times y. But we're going to have a problem because you have two variables. How could you possibly take the derivative with two variables? You can't. You have to get rid of one of them. Which one can we get rid of? The x, the y, the 2x. Is there anything we know about y?
No.
Yes, there is.
Y equals
Oh,
16 minus x.
Y equals the square root of 16 minus x squared. Oh my God. So this guy here is your constraint. It relates the x's and the y values. So your area is 2x times the square root of 16 minus x squared. Let's see.
But we do X. So why?
What do you mean you knew x? Well, hold on. This is the, like, we peeked behind the curtain, we knew what the x was. Jeanette.
But what if you get an application problem where they don't give you the y value?
Oh, you mean like tomorrow? Yeah, good. Jeanette, I love the fact that you always read my lesson plans in advance. So the area is 2x times the square root of 16 minus x squared. This is what we're trying to optimize. This is what we want to make big. So what do?
Derivative.
We find the derivative. Go find the derivative. We're going to set it equal to 0. We're going to do all the things. What's that derivative?
2 times grade 16 minus
Oh, good. I heard it from somebody.
plus 2x
Product rule.
times
Product rule. All right, we've got 2x times all that stuff there. Product rule says derivative of 2x, 2 times leave the next guy alone, plus leave the first guy alone, times the derivative of square root of 16 minus x squared. Square root of stuff.
Oh,
1 over 2 square root is
Not 1 over stuff.
1 over 2.
Right, on the side here, if I said, hey friends, what's the derivative of square root of x? Everybody would tell me? 1 over 2 square roots of x. So what's the derivative of square root of stuff? 16 minus x squared times the derivative of the inside, which is negative 2x. And if I'm just thinking about how I'm going to score this, coming up with the initial equation is probably going to get you a point. Coming up with the derivative is going to get you 2 points. We found the derivative. Why?
To find
find
the
Mine is
The candidate.
To find the candidates.
Yeah.
Where do candidates come from?
Equal to 0.
Setting the derivative equal to 0. Okay, that's actually part of where the candidates come from. Set the derivative equal to 0, or a prime does not exist. We want to look for both. All right, 2 times the square root of 16 minus x squared. 2x times all this times negative 2x. If you guys don't mind, I'm going to write it as negative 4x squared over 2 times the square root of 16 minus x squared. Trust me, it's better. 2x times all this times negative 2x. We're just multiplying fractions. Multiply the numerators. Multiply the denominators. I expect you guys know how to solve that equation.
Oh, you do the
Are you waiting?
Especially if you're running in my gang.
oh, the fraction killers.
Right hand gang.
Yeah, we have
No, 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 not right-hand rulers, not physics, no. I would multiply everything by the common denominator, which is 2 times the square root of 16 minus x squared. You don't have to solve it this way, there are other options, but check it out. 2 square root of 16 minus x squared times 2 square root of 16 minus x squared.
2 times 16 minus x squared.
It's not 2 times 16 minus x
square root
squared.
of 16 minus x squared.
2 square roots of 16 minus x squared times 2 square roots of 16 minus x squared is 4
Oh, you know.
times 16 minus x squared. 2 times 2 is the 4. Square root of 16 minus x squared times square root of 16 minus x squared is 16 minus x squared.
So smart.
I tried. Minus 2 square roots of 16 minus x squared times 4x squared over 2 square roots of 16 minus x squared.
8x.
Negative.
2 square roots of 16 minus x squared times this guy over here. The 2 square roots is, those guys cancel out. And you get minus 4x squared is equal to 0.
Oh.
You're multiplying everything through by the 2 square roots of 16 minus x squared. Stay with me. Brilliant stuff's about to happen. If I distribute, you get 64 minus 4x squared minus 4x squared is equal to 0. That's 64 minus 8x squared is equal to 0. This is nothing but algebra, so I'm going to go fast. 8x squared equals 64. X squared is going to be 8. What's x going to be? Plus or minus the square root of 8.
What's that number you showed us?
Okay. That's where a prime is equal to 0. Did you listen?
Isn't the 8x squared supposed to be equal to negative 1?
No, I added 8x squared to both sides. Okay. So this is where a prime is equal to 0. Is there any place where the derivative does not exist? Look at the derivative. Is there anything that would cause a problem for the derivative?
0.
What would cause a problem for the derivative is if you have 0 in the denominator, if you're trying to divide by 0. So there's no division happening over here, I'm not worried. How about over here?
Yeah.
What value would make that happen?
Plus or minus 4.
4
Negative.
and
Negative 1.
negative 4. Okay? So x equals plus or minus 4. So right now, we've set up our equation, we found the derivative, we found where the derivative is equal to 0, we found where the derivative does not exist. This is meant to be a hard problem, okay? So if anybody freaks out, this was meant to be hard. Yeah.
How come for this one you found it does not under this not exist, but the other ones?
Yeah.
Say that again?
For this one you found that does not exist, but on the other one you did it.
Thank you. On the last problem that we did when we found the derivative, it was like a polynomial. The derivative always would exist if it's a polynomial. Here, because we are potentially dividing by 0, you could have a place where the derivative doesn't exist. Okay, hold on. We've got about 3 minutes left. So we found the derivative, we found the candidates. Did we forget anything?
Yeah, the interval.
The answer?
Well, we haven't gotten to the answer. We haven't forgotten that. Candidates, we found our candidates.
So then you mean to depend on all your close intervals.
Did we ever actually have a conversation about the interval? No. Let's come back to that. What's the biggest x could be?
Half a bar.
What's the largest that x could be? Look at the diagram. 4.5? The y value is the square root of 16 minus x squared. What's the biggest that x value could be? What's the largest x could be? There's an actual number I'm looking for. If you look on the diagram, if you think about the fact that this rectangle is inscribed in the circle, the furthest you could go is 4. 4 spaces to the right and 4 spaces to the left. What's the smallest?
0.
-4.
0.
Oh, wait, what?
Right? You actually don't move. So if we're looking to evaluate, we have endpoints at 0 and 4. Those are the endpoints. Candidate? Hold on. Do we have any candidates that are inside this interval?
8.
Not 8. And is that in the interval?
Yes.
Square root of 8 is less than square root of 9, square root of 9 is 3. That seems to be okay.
Yes.
So x is the square root of 8. All right, let's do it. Find the area. What's the area if x is equal to 0?
0.
2 times 0 times square root of 16 minus 0 squared is 0. And hopefully that makes sense. I went 0 from the origin. I have no area. What if x is equal to 4? That's 2 times 4 times square root of 16 minus 4 squared. Do you guys know what that is? 0. And if x is the square root of 8? 2 times the square root of 8 times square root of 16 minus square root of 8 squared. Stay with me real quick. Square root of 8 squared?
8.
8. 16 minus 8? 8. 2 times the square root of 8 times the square root of 8. Square root of 8 times square root of 8 is square root of 64, which we also know is 8 times 2.
16.
Wait, what?
Oh!
What? Oh my god.
The largest possible area is 16.
It was there all the time.
Exactly what we got from our little cheat step.
Oh, wait.
Anybody know what the square root of 8 is as a decimal?
2.8. Oh my god.
Oh,
Right around
way.
2.82.
Mr. D, you blow my mind.
I try. See you later.
I love this lab.
Those of you that scored below an 80 on the test, we're meeting at lunch. It has to do with the x value is the distance from the origin.
Oh, so just the end.
Thanks for sabotaging me there.